Hello everyone, this is LeetCode 876, middle of the linked list. So done this problem in Python, now we're doing it in C++. So given the head of a singly linked list, return the middle of the linked list. If there are two middle nodes, return the second middle node. Um, so the way this is gonna work, okay, is if you've been following my videos, linearly, chronologically, right? Because we're going through the grind 75 list right now. We've done a problem before called linked list cycle where, you have a cycle in the linked list and you need to find out where, if we're in a cycle or not, return true if we're in a cycle, return false if we're not. Now, to solve that problem, we used the tortoise and hare algorithm where we had a slow and fast pointer, and we just kept going until the fast pointer reaches a null node or the next node is null, and we know that in that case the linked list has no cycle, right? And if the slow pointer and the fast pointer are ever equal to each other, then we know we're in a linked list cycle. So we can use the same algorithm here, the tortoise and hare algorithm. And in those videos, I've said we're going to run into problems in the future where we're going to use the same algorithm. So it isn't like useless. It's actually quite useful because it's used in multiple problems. Well, this is the problem that I meant, right? And there's probably other problems out there, but yeah, same algorithm that we're going to use. So let's make a slow and a fast pointer. Okay, so we're going to say list node of s is equal to head, right? Node of f is equal to head. And we're going to say while the fast not null and fast of next is not null, right? The slow is going to go by 1, right? Tortoise and hare algorithm, the slow pointer goes 1 step each iteration, the fast pointer goes 2 steps each iteration. So given that the fast pointer goes twice as fast as the slow pointer, right? By the time this fast pointer reaches the end of the linked list, the slow pointer should be in the middle, right? Because the fast pointer moves twice as fast. So, for example, at this 1, the fast pointer is going to go 1, 2. Okay. F is not equal to null. F dot next is not equal to null. Okay. Go 1, 2. F dot next is null. So we would stop here. So we went 2 iterations. So at that point, the slow pointer would be 1, 2. So it'd be here. So we'd return this node, right? So we'd return the slow pointer. Now let's check example 2, right? If there are 2 middle nodes, meaning if there's an even number of nodes, then we need to return the second middle node. Okay, so for example, here the fast pointer 1, 2. F is not null, f dot next is not null, right? 1, 2. F is not null, f dot next is not null. So we go 1, 2. Okay, now f is null. So there's 3 iterations. So the slow pointer would go 1, 2, 3. So our algorithm would return the second middle node with this algorithm. So it would work. This algorithm will work regardless of whether we have an even or an odd number of nodes, okay? Now, of course, we actually have to return. So we return s, which is what we should return, right? We should return a slow pointer or the middle of our linked list. So yeah, tortoise and hare algorithm. Pretty useful algorithm. You've seen it pop up in a previous problem. Now you've seen it pop up here again. It is a useful algorithm. So it's not that hard to memorize. It's pretty simple. So yeah, just keep it in your back pocket. Eventually you'll need it. So I hope this helped, and I'll see you in the next one.